Having a look at what we're going to go through today. Firstly, a bit of an overview. What is Eplan Fluid? Then I'm going to have a look at how you get access to it, or do you already have access to it and where to find it. I'm going to have a look at who it's suited for specifically. And then why would you go into this Eplan Fluid and then start using it? Then I'm going to go into a bit of a detailed guide in terms of getting started with Fluid, having a look at the where to find the symbol libraries, set them up and use them. We'll have a look at the data portal and what's available for use from that. I'll go through some good drawing practices. I'll look at use of fluid macros. We'll look at the cross references and how that works with the electrical system. Finally, we'll finish with some fluid reports, fluid use with ProPanel, and then the 3D routing of fluids and tubes. All right, to start with, the what, how, and why of Eplan P8 fluids. So what is P8 fluids? P8 fluids is actually as I said, pneumatics and hydraulic symbols and systems. It's the fluid power engineering element that's included in Eplan. Originally, it was an individual element, but it's now in there as part of P8, and I'll show you that in a second. And it's about the symbols, connecting them, drawing fluid schematics, the layouts, automatically generating reports, being able to do 3D routing for it, which aids with the automation of production, data portal prefabricated parts that are available and using those. Generating your electrical fluid schematics, so the combination of your electrical and fluid schematics in a single project. And this is all within the Eplan ecosystem and Eplan projects, which is beautiful. And it's not to be confused with Eplan pre-planning, which is your P&ID planning system. So looking at the Eplan ecosystem here, in the middle, you've got your Eplan core. Previously, fluids was an independent add-on or standalone package you could purchase, and now it's actually included in electrical P8. So it's now part of the base P8 architecture. And to be able to check if you have access, Eplan Fluid is now included in all Eplan P8 electrical packages as of 2026, except I believe not in the basic package. It highlights the importance of upgrading your packages to 2026 to make sure you get access to it and it's incorporated. And you may already have it in your Eplan software and it's hiding in the background, and you may have seen little elements of it, but didn't even know you could utilize it, and it's in there. So where you'll find it is if you go under help within your Eplan and look under your license add-ons, you'll actually see it listed there as Eplan Fluid. For the 3D routing of the fluid power systems, the hoses for pneumatics and hydraulics, you'll need either P8 with ProPanel add-on, or you'll need a P8 standalone and ProPanel standalone to be able to manage this. Having a look at who it's suited for, it's principally designed for mechanical or mechatronics engineers. This is because obviously it's the pneumatics and hydraulic systems. But even without experience, I have no historic experience in either of these. It's a good starting point for fluid diagrams if you want to expand your current electrical schematics and get into these elements. And it brings in efficiencies from P8 electrical. All the efficiencies you're used to in your electrical schematics now cross over for quicker fluid designs and to be able to design the fluid systems yourself. So you might be able to in-house them rather than outsource them. And then why would you continue with, a lot of other fluid packages, primitive graphic only. So we're talking CAD packages without that Eplan kind of database backend where everything links together and it auto-generates reports. Eplan Learning, the e-learning online videos and the Eplan Cloud has Eplan Fluid videos, a whole small seminar on it. And the Eplan Sample Project provides sample circuits for use. And we'll run through quite a bit of that today. And I'll show you where to find it and get familiar with it from what's already provided. Just a quick disclaimer, as I said, I'm electronic engineer. So bear with me today, and a lot of this I've learned in the last couple of months, and it's been a pretty quick onboarding, but I've found it pretty comfortable. So why would you go down this path? Why would you use Eplan Fluids and start getting into it? Basically, it provides more transparent and easier to follow designs for your fluid power and for the control devices connected to it. And we're talking about field valves, control valves, etc. It provides for faster maintenance of installs, a better fault finding if you're using a tablet with a PDF on site, and it allows for respecking of parts if needed. If you've got a blown valve, you can actually run through the PDF with a tablet quickly and be able to find what the exact part is you need to find a replacement for. So it can aid in that maintenance massively and speed up time there. It allows you to correlate electrical control devices with field fluid device tags. And by this, I mean, if you're looking at a valve and you're wondering where does this connect to, you can follow it back to the PLC connection within the PDF schematic, and then it will show the electrical connections for those valves. It allows for digital twinning, the Pro panel side of this, for fluid junction distribution boxes for checking, and this is mainly for space checking. What space do I need? What size box do I need? How much am I going to fit in it? Have I got the connections pretty aligned and laid out in the way I want to? And it can produce nice 3D graphics there. And it introduces production automation elements. And we're talking here about, say, like the Perforex panel cutting automation to your fluid designs. So those fluid junction boxes with, control valves on the surface and on the edges, push fittings, can all be done and automatically designed and cut out and checked. So a lot of advantages there from diving into this Eplan fluid. I'm going to go through a bit of a detailed guide, and this is going through the step-by-step diving into fluids and where to get started and start getting some ground with it. So getting started with fluids, there's existing projects and project templates. Your existing projects and projects templates can be used. You don't need a specific project type to use fluids. It'll just seamlessly integrate into your electrical projects. You can add fluid type pages, specific fluid type pages that I'll show you, or you can just use fluid devices on multi-line schematics, being careful with depending what representation you want. That's obviously the fact that they've got overview representations and macro types. They've got the device representation as well as electrical and sometimes mechanical representations of the valves. But we'll run through that and I'll show you how to step through and see what they all are. There's a sample project available that comes with Eplan, which is the Eplan sample project, doubly named. And then within that, I will show you where to exactly find how they have provided the demo pages for fluids. But effectively, you'll find it under a lot of different sections, this GOA, K2, MM1, and you can use this PDF or the video from this as a reference, but it's always under this B2 plus Y1. And you can see down here B2, Y1, and that's where all your fluids are located under these subcategories, under these location designations. You can synchronize the library out of the demo project that's provided by Eplan if you want, but the PNE1 ESS library is the principal library we'll be looking at, and that actually comes with Eplan. It should be in your Eplan symbol library directory in your master data, and you should be able to get access to this instantly, regardless. The data portal is a massive hand here. The data portal has Festo parts, is the principal supplier. It has a lot of Festo parts, and we'll go through that in a second. But if you do need to create a part, it's probably best to try and find something that is a Festo equivalent and then clone it, which will save massive amounts of time. And then last, as I said, there's extensive macro use possible. So this is both overview macros, electrical macros, 2D schematic macros, as well as the 3D macros and placing in 3D panels for the Pro panel side. So there's a lot that you can actually do. And a lot of this parallels exactly what you go through already with electrical devices, functions, and parts. To have a look at the symbol libraries, as I said, the PNE1 ESS library should already be installed in your symbol library. You can search for it in your Windows file structure under your master data, and you should see it there, both with the library file and the library database. You can also use filters when you go to insert a symbol, and using these filters, you can find fluid power symbols from other libraries as well. And I'll run through this in the live demo and show you exactly how to set this up and run through it. It may need, yeah, you may need to add it to your symbol libraries in your project settings. So on the bottom left here, I have the symbol libraries that my project is currently using. They may not be, they won't be defaultly included usually. So you need to add those symbol libraries in. Again, I'll show you this, where to find them and where to add it in when we get to the live demo. Just a basic sample of some of the symbols at the bottom here. And you can see that even under these different libraries, this is a symbol library viewer on the right. You've got your special library, your IEC topology symbol, M20, and all of these have fluid power subcategories that you can search through. Alternatively, there is a filter preset up for pneumatics, and a couple of them there for hydraulics, which are quick and easy to use if you don't want to go through setting up the filters. Looking at the data portal use, again, nothing to be afraid of here. The data portal is quite amazing. Festo is a one-shop stop for this straight away. Festo have a very large representation in the Eplan data portal. The Festo website, this is the subcategory for New Zealand /NZ/EN, has a search tool, which is amazingly useful, and you can find mostly equivalent to whatever part you're using, and then probably find a Festo part in the data portal that has most of everything set up that you need to use, and you can make small alterations or clone the part if required. So it saves a lot of time by finding that part and cloning it rather than create a part from scratch. As I say, as I'll probably mention later, with all good practices, once you've used a part, make sure you create it properly and keep it for that reusability. So in the future, you can use it again without having to go through the process. Parts with all data types available in the data portal. Festo has over 50,000 parts, which is incredible. I think it's already gone up by a couple since we've done this, since I've made this presentation. Of that, 38,000 of them come with schematic macros ready to go in place. Of that, a further 12,700 come with 2D graphical macros, and this is your 2D panel layouts that you can do with the graphics as well as overviews. And then 28 of them come with 3D models, but there's nothing stopping you from actually grabbing the STP file and making a 3D macro to go with your parts. Along with that, the data types, using the data portal, I'll run through that. I'll show you how to search for just Festo. I'll also show you how to change or check which data types are available, how to see them. You can see the list here of what data types it represents. But there's also background data values or metadata that belong to only fluid parts, and this is in your parts database. These are already included, and you can see down here max working pressure, control range, flow, thread, etc. These properties are available to use and can be carried through to reports from your parts data. So having a quick talk about good drawing practices. Pneumatic symbols are defined in the ISO 1219. If you're a mechanical engineer, obviously this is probably more relevant. And this defines all these symbols for pneumatics and hydraulics. But in accordance with IEC design, it's always best to keep energy flows from top to bottom or left to right. And there are places in the sample project, Eplan sample project, where they have not done this. This is one valve off a valve bank shown at the top here. We'll go through these valve banks in more detail shortly, but you can see the valve here is actually placed with the inputs or control lines on the right, which is lines 5, 1, and 3, and then it's control lines on the left, sorry, which is 4 and 2. So this is backwards to me, but it's very easy to manipulate these and change them around, and we'll run through all that. You can see a 2D representation that you can place in your panel layout, as well as, this is probably a better way to do your designs here. And I always suggest labeling your control lines by putting these port numbers on it. It's very clear and transparent. Whereas looking at, the overview here, it's not so transparent. So take your time, put your port numbers on there. And one thing to keep in mind is when you give these schematics out, same with electrical, someone in the field has to wire from them or has to assemble valve banks from them. So the more transparent or the better you convey the information, the easier it is for them to work from. So talking about use of fluid macros, as I mentioned, fluid devices can come with any kind of macro similar to electrical devices. There's overview macros, and we can see up here there's one valve bank card or one valve for a valve bank, and you can see it's got a backing system as well as the valve itself sits on the front. It comes with both the overview, the schematic macro, which is down the bottom here, which is the connections and the control details. You can see the 2D layout macro, which is presented here. And then on the right-hand side here, you can see it comes through with a beautiful 3D macro as well and can just snap to DIN rail. And it's as easy as to place as any other device 3D macro that comes with Eplan. You can also have connection points and drilling patterns. Connection points obviously allowing for the routing of tubes and hydraulic hoses. And the drilling patterns, if it was mounting directly onto a mounting panel, they can carry through to go to the automatic production levels of ProPanel. As I said earlier, with all good practices, it's better to update the macro after use. So once you've used it, you've cleaned it up the way you want it, and then save it for fast future placement. So you're not reworking a macro, and it's good to use for future fluid stuff. Looking at the cross references, similar to a PLC, the cross references in the overview, both for the individual fluid valve front side as well as the valve backing backside, has cross references to the more detailed schematic from the overview to the fluid schematic. You can see the valve at the bottom here with the backing card at the top, the backing plate at the top. These cross references jump back and forward between these, which is lovely. And then from there as well, you've got your coils that drive this valve. These cross-reference directly to the electrical schematics. So on the PLC cards. So in this way, your whole system links together, your project links together, and these carry through to the smart PDF as well, meaning that a well-drawn system can jump back and forward very quickly through everything needed. It's good for fault finding as well on site. If you've got a tablet and the PDF on that tablet, you can just jump back and forward and find everything needed. Looking at the fluid reports, parts lists filtered by engineering type. The engineering type is classified as fluid power under Eplan, and you can create a parts list like you would for any other device list with the device tag, its description, type number. You can customize all these reports in the exact same way as electrical, supplier, and part number. Obviously, you can see the Festo part numbers are carrying through here. Connection lists are also possible, fluid connection lists. So you can see here the connection designation, its source and target in terms of valves. I think there's a panel side push connections. You can see the cross section, diameter of the tube, color of the tube, source page, target page, and tube. And I mean, besides the fact these are automated, you can generate these automatically, which is one of the beauties of Eplan. One thing to carry away with this is that it's not that much different to electrical. Everything's very similar to the electrical parts you're already using. And I thought a lot of it would be new and different, and it wasn't. And it was very familiar to get involved with and just progress forward. And as I said many times, these carry through to the smart PDF as well. So you can click on the valve connections here, the connection designations, and it will jump to the page in your PDF that has those. So very useful. Looking at fluid use with ProPanel, again, very similar to the electrical. 3D parts are available from the data portal, which I've shown you, those 3D macros with some parts. You can generate your own 3D macros in a 3D macro project. A little bit more of a bigger project, a bigger process, but good to get used to. And once they're done, you can just reuse them. You place them in the exact same way as any other 3D macro, and they snap together, and you can create snap points, mounting points in the exact same way. And they have connection points and drilling patterns that you define exactly the same way as you would on a VSD or any other kind of device or MCB. You can generate model views of your ProPanel valve layouts. These are model views taken from the page space on the left. You can see the 3D macros come through with great amount of detail when they're brought in correctly. And you can see where you're kind of aiming here, generating a beautiful 3D model of the entire panel. And this can be included or exported to the STP, included in the bottom of your PDFs, and it adds to the whole project presentation. 3D tube routing is probably the most advanced bit of fluids. Again, I thought this would be a massive step, but I've done a bit of 3D wire routing in ProPanel, and I found it to be very similar. I had a little bit of trouble working with the Eplan sample project and how they'd set this up, but once I started getting some of it running, was not a problem. So tube connections, very similar to wire connections. They use the same connection point method, the same connection points. There's no difference between them for the wire routing. If you've got an understanding of the ProPanel wire routing, as I said, 99% of the knowledge for the tube routing is already there, no problems. So what it will do as well is provide tube links back to the schematics, and that'll allow you to generate summaries of tube links to be able to get total bill of material for how much tubing you need for your pneumatic jobs. And the wire center, although it's called a wire center, works perfectly with tube routing. And this is the wire center is a feature brought out with with ProPanel 2026. So that can be used, and we'll go through all this. So let's have a look at how all this goes together and jump into Eplan. Alrighty. So the first thing we're going to do is just have a quick look at the sample project. As I said, running through this might be a bit overwhelming because of the amount of classifications I have in here. But if you break down any individual areas of this, as I said, it's always under B2, Y1. And then this section here is going to be pneumatics. So what we've got here is a service unit, which is effectively the schematic. It's got a bit of a model view here of the actual 3D layout, and they've been combined them together, as well as definitions of tubes. Some of these symbols will be a lot more familiar to some mechanical users rather than myself. But we've got panel edge connectors here, which are push fitting connections. The cross references are utilized. In the bottom here, we have the valve coil here, which links back to the electrical side. So working through this and starting to find how they've used it and what they've used it, and then maybe borrowing from this project if you wanted to use it as a start is a great starting point. Here we can see a bit of an electrical interaction. We have the valve defined back here with the cross-reference for that valve, which would link back to the pneumatic side. And then just some model views carried through from 3D space. So the sample project's a great place to start diving into fluids. If we look at our own project and we want to add pages in, we can use our existing electrical projects no problem, as we did previously. Valve bank new, we're just going to add in a page. We have the options of this fluid power schematic, which is your fluid schematic pages, fluid overview, function overview, which is the overview pages, obviously. And then we still have our multi-line schematics and our model view pages, which we can use as well to combine all this together. So that's where we find the fluid pages and start adding them in. I've taken these pages at the top here out of the sample project just to summarize them and have an easier look. So what we've got effectively here is we have the valve bank. We have these backing cards, which you can see surrounding the front valves. They're banked together and they have a series of cross references. These are defined as the master function, so they're not done any differently to an electrical overview design or a PLC layout. We've got a bit of a model view here where they've added a rectangle to highlight what is shown. And then stepping through these next couple of pages, it's taking care of the cards individually and breaking them out. So you can see them in terms of the schematics, the layouts, and then jump back and forward. So if I was to jump back to the overview, I can choose one of these valves. I can see the pages it's represented on, and then it will take me exactly to that valve. And I can jump back as well. And it has other representations as well in terms of more detailed breakouts here. And this is the back-end supply for it, as well as the mufflers. So that's kind of layout for your pages, or how to start laying out fluid devices in your project, obviously with overviews, individual valve breakouts on different pages. On this side, we have a combination of what's inside the panel. And then on the right-hand side, we have the field valves and then the connections between it. So that's how they've made the segregation there. Much of the same stuff on many other pages. And finally, at the bottom here, we have what you've seen already is this is the electrical interaction, details of the service unit. Yeah. And then like just an example of the model views that carry through. So when we talk about symbol libraries, to start getting your symbol libraries into your project, you want to call up the settings. I have a settings shortcut here on the bar, but the other way is just to go through File, Settings, and then under here I can open my project, and Fluid, and then Management, and then Symbol Libraries. And you just want to add them in here. I would suggest adding this PID ESS as well. That has some additional fluid symbols that are very useful. So I've got the two libraries added at the bottom there. Once they're added in there, if I was to go to my own pages, like a fluid schematic here, for now, to insert them, you would just use your insert symbol, or obviously up here, insert symbol compatibility. So I use my shortcut key for that. And then it can be a bit overwhelming to try and find it in all of this. Obviously, the PNE1 ESS library is nearly all fluid symbols, which you can see on the right-hand side here. The PNID has a combination, but this is more overview-like symbols that you may use. And under these classifications, they have electrical, fluid power, etc. The preset up filters that you can find quickly is by dropping down the filter here, you'll have pneumatics already set up. This comes with Eplan, and choosing that obviously just gives me the PNE1 ESS library. But you can create your own filters. So I have one here called Fluid Power. And if I was to show you how I created that simply, I added a new filter simply with functional definition area as fluid power. I chose fluid power and added all of these in. I didn't have to add them in individually. And then when I added that in, it went through every library and just found the fluid power sections of them. So it breaks it down and makes it easier for me to find fluid symbols quickly and insert them into the project. So that's how to set up your project, how to start putting in pages, how to get your symbol libraries, how to get access to the symbols. It's obviously good practice in Eplan to add parts rather than building from symbols. So if we look at the data portal, I'm just going to go Eplan Cloud Data Portal. And when it loads, I'm going to come down here to manufacturers and select a manufacturer. And this is how you filter your data portal. So jumping to F, I'm going to choose Festo and apply. Done. Yeah, so they've added an extra part in the last couple of days. So they're still building this database. It's beautiful. So you can scroll through here and find the parts. I would preferably use the Festo website to find something similar to what you want if you want to copy a part and use it. And within this, again, under information, it'll have your data types and it'll show you for this part exactly what's available or what's not. If you want to filter your data types, you can come to data types down here, select and say, show me parts that just have a logical macro, apply. Yeah, so 50,000 of, 38,000 of these have logical macros ready to drop on a page and use straight into a project. So that's where you start building your parts database up with fluid parts to use. Obviously, copying the part number and then using it is the best way to place it straight away on the page. And then, as we said, good drawing practices. If I look at many of these, the flow of power is going from left to right or top to bottom. I did say the one exception is kind of these inner pictures of the valves, but it's a one-piece macro from Festo. But a lot of the other ones follow that convention, top to bottom, including these ones down the bottom, as well as the electrical pages. So we're able to find parts, we're able to set up the parts library. Let's have a look at building your first valve. So I'm just going to pop in not a full valve at this stage. I'm going to go for just a valve symbol, um, something basic, and pop it on the page. And like most things, this is given a DT. Um, what you can do as a larger picture is remove that DT and then pop it in a black box. And then it will inherit the DT just like electrical from the black box. What would we add to that is device points. Um, yep, and build it up that way. And then, like any other electrical, fluid connects automatically. You're not having to draw any physical lines here. So in this way, you can start building up your valve. Valves usually involve a few more bits, and I found this quite the only difference I found with fluid versus electrical is you're usually required to add additional bits like showing whether it's a spring return or not. These just get placed on the side. They come in the valve, so there's no point of giving them independent DTs or parts. And then you need to add your coils. And one thing to note, which caught me out, is when I went to hydraulics or fluid power, it missed under this library the electrical engineering sections, which is your coils for your valves. So then I can just drop them in. And I tend to give these unique DTs. We'll call it, oh, well, we'll call this one enable. I'm going to put underscore enable for a reason. This one on this side. Let's go de-energize. And you can move these around as well. So let's call it what? Oh, to energize. Display DT. Sorry if I'm going a bit fast here. Upper center. Insertion point. Let's zero out the X and make it minus 10 centimeters in the Y. Okay. And you can copy and paste formats just to make this one the same. And I'll make that one to de-energize. Well, let's just do one side for now for valve 2. And the reason for that is this symbol here. If I was to remove the black box, you can view valves in the device inspector. So you find the device inspector by view, open, then devices. And if I look at it on the right, I have my devices. I can synchronize selection to find that valve coil. And then if I had pages like this I'm on my own standalone fluid schematic here. I have an electrical schematic page that I've already placed a PLC card. I can then take that valve and just drag it out into the page and then start connecting it up electrically. Put through those in. So what I've got now is I've got my valve to energize coil, connect to a PLC, which links back to my valve. This here I would group together and then I would save this as a macro, as my own macro for how I'm going to use a valve of this type with a part number from that point on, all held within a black box. So now we're able to draw valves, we're able to link them to our electrical and start connecting them together. And that's how you create the macros. If we started looking at the macros that are already available, back to my page space and then to the overview, I'm just going to grab the the backing plate for the valve and insert it. I'm inserting part compatibility here, putting in the valve backing. I synchronized these out of the project, out of the basic project, so I could use them, but these are directly from the data portal. And then we have a valve backing. Do not modify it. What I'm going to do is I'm going to change its name to valve 1. Obviously, it's the backing. So now I'm going to bring up the front bit. Let me just grab a part number that I've put here earlier for quicker use. This is the actual valve. So copying the part number, Control Insert, putting my valve part number. Just a valve. And as you can see, this connects up nicely. These macros are designed to fit together like that. Didn't modify it. I'm gonna get rid of these macro boxes because I don't like them in there. And I'm gonna make this one valve 1. With this as well, you can see there's coils come through automatically with their device tags down the bottom here that I can mouse over. I'm going to change these to valve 1 energize, and this one here to valve 1 energize. Alrighty, and this way we've built pretty much our valve backing and the backing from 2 macros. So you can see these are the schematic macros that carry through. Looking at other macros that come with us, if I was to synchronize selection, it's down the bottom here. Valve 1, no, sorry, valve 2 is in here. So I can then go to the, let's just de-energize. Let's go that one, synchronize selection. There we go. It's up here. So then I can go to my overview page and I can bring in my valve 1. They're not carrying through for some reason. Had a few issues with this, but I have the direct macro from the parts data from earlier, and it brings in the backing module. So in this way, that the valves can be placed directly into the overview, and they have different schematics. The other way to approach this is to insert the valve part number. I'll choose the same valve again. Oh, it's just not liking that page. So you can build up your overview through this way, your overview pages. And then the other option is the valves themselves, but you've seen this already. Under devices, I can synchronize the coils for the valve. We have the coils down the bottom here. Sorry, this coil here. Energize and de-energize. And then I can go to my PLC page. And like I did earlier, I can just drag them out of the devices. This is de-energize, which goes there, and energize, which goes there. Not completely aligned, but this has got little bits there to stop them connecting. Bingo. So you can see in the way you start building up your valve diagrams, both schematical and electrical, and having everything linked together. Cross-reference, as you can see, can come through at the bottom here. Same with this one. Control clicking on that will jump between my electrical schematic layouts back to my valve, as well as back to the overview. I've given these the same name, which might be causing a bit of a conflict. Showing you the PDF outputs. It's the same as we've done with electrical, going into the project title here, clicking on generate PDF output. The other way to do that is file, export PDF. You can choose where you want to store it. If I was just to put it temporary in downloads, sure. And go okay. Color 3D model, okay. I can then go in and without much surprise, find the PDF. And you'll see the cross references is carried through. And again, clicking on the cross references in a PDF takes me to the page and allows me to jump back and forward to where they're used in the project. It's quite useful. Alrighty. For the reports, I have a few reports here based on this project. Fluid parts lists, which we talked about. Again, no big surprise. It's still the same form type. There's no change in forms from device lists. But what I've done differently is if I was to open how I generated this report, I've created it under templates. I've created the parts lists. I've named it fluid parts lists, and I've put in a setting called filter settings fluids. So my fluids filter is just using generic product group fluid power. This allows me to produce a report based on only the fluid stuff used. A similar report I've created is under connection lists. We have connections and we have cross-section. I've chosen any fluid connection which has an actual value for its cross-section diameter, means it's properly labeled. And again, that functional definition is tube. So those two reports, when generated, produced down the bottom here, we have our parts lists. In the PDF as well, you can click on the connections and parts and jump between them. Fluid list as well, clicking on the connection takes you to the exact connection. And here, as I showed you before, we've got the connection designation, the source and the target, the cross-section diameter, color, etc. If we were to look at the 3D placement of these, if we jump into layout space and test, if I was just to remove this, we have effectively a demo panel with a bit of trunking, a bit of DIN rail placed. I can find the macro or take it out of my device spaces and place it directly onto the backing. We can see if this will go. These are not carrying through because of the project linking. But I have them under C drive 26 data macros fluid webinar, and this is one I created myself because I merged all the parts together of the valve. And bringing this in again, it just snaps on and links like any other 3D part placement in Pro Panel. Hit on modify, and you can see it places it down perfectly and sits on the DIN rail. And building up these valve banks is exactly that easy. Looking at a completed layout space that I've brought in from the demo project, we can get some beautiful looking 3D valve banks with enclosures. I'm just going to hide the doors. And within that, you can see everything has a 3D model brought through from Festo. And from here, we can actually do our wire routing. So looking at the wire routing, we have a connection navigator under view and then connections. And this doesn't just show the wire connections, it'll also show tubing or hydraulic connections, pneumatic connections as well. And the other shortcut that's now been put in 2026 is the wire manager, the routing manager. So that's under edit and then wiring manager. And what this will do is it'll allow you to click on an object in Pro Panel and say, show me all connections. And it shows you all your connections that are routed or not. And what you can do, they hide by default, but showing all connections will show you what's routed and what's not. And we can just remove these that I've test routed already. And when we try and route them, we'll probably get an error because it won't auto route because of the way they've done the connection points. If you know about routing, it has to have a path, connection path, but these happily free route. So the way that Eplan's gone about this in their project is by free routing. Clicking on free routing, you can see it generates that cable. Again, with these ones here, same thing, route, I can free route it, and it will build that link of the hydraulic connections. With those connections, once they're routed, it shows in the wire connection manager that they're routed. I can then jump back to the 2D connection, it'll show it to me. And then opening this up, you can see it carries that connection length back through to your schematics, closing the loop.